Okay, in this podcast we're going to talk about word equations. Alright, so a few things we need to keep in mind when we're doing that is the first thing is we need to pay attention to diatomic elements. So you need to know that there are 7, and remember on the periodic table they form a 7. Nitrogen, oxygen, fluorine, chlorine, bromine, iodine. Those are 6, and they point to the 7th, which is hydrogen. Okay, so when they are in the equation either as reactants or as products, you need to show them as diatomic. So an example of that would be is if we said water decomposes into hydrogen and oxygen, we would write that as water, H2O, decomposes into hydrogen. We need to show it with the 2 and oxygen. Now be careful because we only show them as diatomic when they are in fact alone as an element that's either a product or a reactant. When they're in a compound, it might be a 2, but they're just as likely not to be a 2 because it's just a balanced formula. Okay. The next thing we want to pay attention to is you'll need to be able to identify the states of matter. In order to do that, there's a few rules of thumb, lots of exceptions to these, but in general, unless you're given better information, these are the assumptions you should make. And you can write these on your green sheet, and you can use them when you're taking your test. So we should assume that all metals and all metalloids, those along the stair step, are going to be solid with the exception of mercury, which, as you know, is room temperature, a liquid. And for all these, we're talking about what's the state of matter at room temperature. Nonmetals are mostly gases, and in our periodic table in our classroom you can tell because they're in red, but there are a few that you need to know. For instance, carbon is really that what we call lead in a pencil. That's really carbon. Carbon is black. It's also ash, so it's black. It's a solid. Sulfur is deep, pure yellow solid. So you need to know carbon, sulfur, and phosphorus are solids. There are a few others that are solid, but again, you can write them down or you'll see them on the periodic table when you were taking the test. And there is one nonmetal that's a liquid, and that would be bromine. But all the other nonmetals are gases. So we're talking about elements here. All ionic compounds, assume they're solid, right? They make crystalline solids at room temperature. Molecules, we're going to assume that they're liquid unless I tell you otherwise. If something says it's dissolved in water, we're going to assume that it's aqueous, which means dissolved in water. If we talk about having a solution of something, we are going to also assume that that's aqueous because water is usually the solvent that we're using. It's possible we'll say a solution of something, let's say in toluene, and then it won't be aqueous, but we're going to assume it's aqueous unless we're told otherwise. Okay, the other thing we want to watch out for is when it says something reacts in air, it means that it's reacting with oxygen, and we want to show oxygen as the reactant. So if we say magnesium reacts with air to form magnesium oxide, we're going to write that as magnesium reacts with oxygen to form magnesium oxide, plus 2 minus 2. Okay. If we say sodium reacts with iron 2 chloride, iron and sodium chloride are formed. So let's do this one. We have sodium and iron, that's FeCl2, are formed. We form iron and sodium chloride. Okay, sodium is a metal. It's going to be a solid. Iron 2 chloride is an ionic compound. That will be a solid. We're going to make iron, which is a solid, and sodium chloride, which is also a solid. Okay, when lighting the Bunsen burner, we ignite methane, which reacts with air to produce carbon dioxide and water vapor in a lot of heat. Okay, so we've got methane. Now we know methane is a gas, right? It's a gas that comes out of that jet. It reacts with air, that's oxygen, and it produces carbon dioxide. which is a gas. We know it's a gas, and water vapor. The fact that we call it a vapor tells us it's in the gaseous form. Now it says also produces a lot of heat, and we can say plus heat, although heat is really not a physical product.